Okay, what we've got here is quite a long exam question, so I'll be as quick as I can, but this is an extended piece of work. Okay, so we've got twins Alec and Eric. Okay, they're cricketers. The probability that Alec plays is this, the probability Eric plays is this, and the probability they're both selected is this. So I can see that these are all plain probabilities. None of them are conditional, and it does hint that I should use a two-way table. If it's not conditional probabilities given, then start off with a two-way table. I'm going to draw it up here. So the events are that Alec either plays or does not. Okay, and that Eric plays or Eric doesn't. And I've got totals, and I've got a grand total, and the total of probabilities is 1. So all I need to do is fill in the correct probabilities. The probability that Alec plays is 0.85. So that's the total of this column must be 0.85. 85. The probability that Eric plays is in total 0.60, but the probability they both play is this 0.55. 0.55. Okay, and now I can use subtraction to find out the missing places. So if this adds up to 0.6, this must be 0.05, and this one, if they add up to 0.85, must be 0.30, and then these add up to 1, so this is 0.15, which gives me, in this column, this is 0.10, these add up to 0.40, and lo and behold, those do add up to 1. So I've now got my two-way table, so it should be very easy to work out these three things here. So you would do this separately on file paper. Use in your booklet, use the space at the bottom, but I want you to be able to see the questions at the same time as my answers, so I'm going to be very evil and write down the answers next to the questions. The probability neither is selected is 0.01, so this is actually just C, the table. The table is sufficient working for that, so that's okay, that is all right. And then find the probability that at least one of the twins is selected for a particular game. Now I'm going to do that using the idea that the probability of at least one that we saw previously is workable out as 1 minus the probability of none. I could add up 3 probabilities, but I'm going to do 1 minus the probability that neither of them play. So it's going to be 1 minus 0.10, which is 0.9. Is my answer for this one. Find the probability that exactly one of the twins is selected for a particular game. Well, now I've got the probability that either Alec plays and Eric doesn't, or that Eric plays and Alec does. So therefore this is 0.30 for the first one plus 0.05 for the second one. I can add these probabilities because these are separate outcomes. These can't both happen. So this is 0.35 is my answer for that one. Okay, so my presentation is dreadful, okay, but my answers are fine. Can you make sure you present those solutions properly in the big space? Right. Part B, the probability that the twins' younger brother Cedric is selected for a particular game is now R. So now it varies according to what option we've had. Now you could do a tree diagram. You're given conditional probabilities, but actually I think we can do all of these directly using the formula. Okay, so for example, this first one, we want the probability that Alec plays and that Eric plays and that Cedric plays. They've all got to play. Well, this is, the first part of this is the probability that Alec and Eric both play, which I've got from my table. It was back up there, it's 0.55. So 0.55 is the probability of these two both happening, and now I've got to say that as well as that happening, Cedric's got to play. So I've got to use the correct conditional probability, okay? Given that both of the twins have been selected is what I've got. So I need to multiply this by 0.3, okay? So I can use multiplication of probabilities as long as the final probability, or the probabilities I multiply by, take into account what's already happened. So 0.55 times 0.3 is 0.165, I think that is. Okay. All right. So that's my answer to 1. And for 2, now I've got to do this in some different ways. At least 2 of the 3 brothers are selected. Okay. Well, I could carry on working from what I've already done. I found the probability that all 3 play. Now I can go through the different ways that 2 of them play and the third one does not. Okay, so one way of doing this is to say, okay, I want the probability of Alec playing and Eric playing, but Colin not playing, Cedric not playing. Or I could have Alec but not Eric, excuse me, but Colin does play. Or it could be Alec doesn't play and Eric plays and Colin plays. Well, for this one, it's like the one I did earlier. Alec and Eric both have to play, but this time Colin doesn't play, so I need to multiply by 0.7. So that gives me a probability of 0.385, I make that one. And then for this one, I want that Alec plays, Eric doesn't. Well, I've done that in the table. Alec plays, but not Eric is 0.3. So I need to do 0.30 times, and now I need Cedric to play, given that, okay, exactly one of the twins has been selected. So that's a 0.75 times the 0.75 here. So that's a probability of 0.225. And finally, I could have something similar, but this time Alec doesn't play, but Eric does play. So Alec doesn't play and Eric playing is 0.05. So I can do equals 0.05 times. Once again, the probability that Cedric plays will be 0.75. Okay, because exactly one of the other twins is playing. So that probability gives me 0.0375. Now, what I want is the overall probability that at least two of the three brothers are selected. So I've got here the chance that they all three play, and now I've got the three different ways that exactly two of them play. So I've got four non-overlapping ways in which the event can happen. That covers all the possible cases. So I simply have to total the four answers from above, and I get 0.8125 as my overall probability. The important thing here is that we broke down the events into ones that we could work out. It's not the only way I could have broken it down, but it's worked for me. So that's fine.